Thank you for taking a little bit of your time to watch this video that I've put together, where I am about to dazzle you by showing you why elimination works. I know you've always wondered why elimination works, and so I'm gonna treat you to a little show here as to why elimination works the way it does. So without further ado, I'm going to do this using GeoGebra, which, as you know from class, I'm quite fond of, and I encourage you to also try to make use of it because it will be a wonderful thing for you to explore and should also help give you a visual just to make things more understandable in a lot of situations we're going to deal with. So I've got a system of equations here. As you look over here, you can see I've got two equations in here, and if we turn these suckers on, now you can see the two equations in the plane. And they've also got an intersection here, which I've called S for solution. Now, to find that solution, at least algebraically, we, using the method of elimination, would of course try to get rid of one of the variables. But the idea is we do that by adding the equations together. So why do we add equations together? Why does that do anything that would be remotely related to finding the solution? Well, it turns out if you add two equations together, it'll produce a new equation. How about that? Now I'm going to go ahead and do that, and without changing these two equations, I'm just going to add them together as is, and we're going to get a new line, and I'm going to turn that on here. I actually have it, so there it is, the red line. So just adding the equations together as is without changing anything, nothing's getting eliminated just yet, you get this red line, and notice the key thing here is that it passes through the exact same solution point as the other two lines. Now normally before we start adding lines together, we multiply one of them by a fixed value. So I'm going to call that value k, and you can see I have a little slider for k over here, and right now k is set to 1. And I've decided to multiply equation 1 by this constant. It doesn't matter really which one you pick. In fact, you can even multiply both equations by two different values if you want, as long as they're not 0. But we can get away with everything if we just multiply the first equation by something. And right now that thing is 1, so it's not affecting anything in the first equation. But let's see what happens if I adjust k. In other words, that's going to represent multiplying equation 1 by different values of k. So I'm going to adjust the slider, and you can see as I adjust the slider, this represents multiplying different values of k through equation 1. And what happens is it always creates a new line. So you see there's a whole bunch of different lines that you can create. And the key thing is they all pass through that exact same solution point S. That's the key thing there. Now as you can see, as I've been adjusting this, there is some value of k for which we get a vertical line. And if you remember, a vertical line has an equation of the form x equals, right? X equals a number. And so a vertical line is special in that that vertical line will reveal the coordinates, or the x-coordinate I should say, of the solution. So multiplying by the right value of k and adding the two equations together produces a new line, one of the new lines being, in this case, a vertical line. Okay, so that would correspond to y getting eliminated, essentially. And you get the vertical line passing through the solution, and that reveals the x-coordinate. And then if we change k some more, you can see that eventually, probably should go this way, eventually you'll end up with a horizontal line. So there is a value of k for which, when you multiply it by one of the equations and add them together, it produces a horizontal line. And of course it still passes through the solution point. And a horizontal line has the equation y equals a number, which means that it reveals the y-coordinate. So really the magic here is just realizing that, hey, whenever you add two equations together and they have a solution, it produces another equation that passes through the same solution point. And then we just adjust what we multiply the equations by so that we get a resulting line that is either a vertical line or a horizontal line. And with those together, that reveals exactly what our solution point is. So that's it. It's that simple. That's really what's going on behind the scenes here. So thanks for taking a little time to watch this. I hope it made sense, but if not, I'm sure you'll let me know in class. And I hoped that you will tune in for another video sometime soon. All right, bye.